Hello, and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring rational exponents. This lesson is meant to be an introductory lesson, and you will explore this topic more thoroughly in later courses. Now, in our previous lessons, we've practiced using the multiplication and division properties of exponents, where all the exponents were integers. So, for example, you had things like this: x to the 3 power, or 4 to the negative 2 power. But in today's lesson, we will explore problems where the integers are rational numbers. So, for example, we'll have things like x to the 1/2 power, or 16 to the 2/3 power. Now, rational exponents have a close relationship with radicals. And in the rational exponent property, we have that x to the 1 over n power is the same thing as the nth root of x. So, for example, if I had x to the 1 over 2 power, that would be the same thing as the square root of x to the 1 power. Or if I had x to the 2/3 power, that would be the same thing as the cube root of x raised to the 2 power. So notice that the denominator is the root of your radical. So in our first example, our root was 2, so that's a square root. In our second example, our denominator is 3, so our radical is a cube root. All right. Now let's explore this concept a little bit more. Look at example 1. Rewrite each of the following as a radical and then simplify. So we have 49 to the 1/2 power. So our denominator is a 2, so we know that this is a square root of 49 to the 1 power. Now this 2, this square root, we don't usually write it, so I'm just going to erase it. When it's just a radical, it's assumed to be a square root. And we know that the square root of 49 is 7. All right, pause the video and try problem B on your own. All right, welcome back. Hopefully you rewrote 100 to the 1/2 power as the square root of 100. And you don't have to write the 1 power, which is equivalent to 10. So 100 to the 1/2 power is equal to 10. Now look at problem C. We have 8 to the 1/3 power. This time our denominator is a 3. So this will be a cube root of 8 to the 1 power. And the cube root of 8 is 2, because 2 times 2 times 2 is equal to 8. All right, pause the video and try problem D on your own. All right, welcome back. 64 to the 1/3 power, if I rewrite it in radical form, would be the cube root of 64. And the cube root of 64 is 4, because 4 times 4 times 4 is equal to 64. All right, in example 2, it says rewrite each radical expression with a rational exponent and then simplify. So in problem A, we have the square root of 25. Now remember, if it's not written, it's understood that this is a square root. So to rewrite the square root of 25 with a rational exponent, I would simply write it as 25 to the 1/2 power. And we know that the square root of 25, or 25 to the 1/2 power, is 5, because 5 times 5 is 25. All right, pause the video and try problem B on your own. All right, welcome back. Hopefully you rewrote this as 64 to the 1/2 power, which is equivalent to 8, because 8 times 8 is 64. All right, on problem C, we have cube root of 27. To write that with a rational exponent, we would rewrite it as 27 to the 1/3 power, which is equivalent to 3, because 3 times 3 times 3 is equal to 27. All right, pause the video and try problem D on your own. All right, welcome back. Hopefully you rewrote this as 125 to the 1/3 power. So the cube root of 125 is equivalent to 125 to the 1/3 power, which is equivalent to 5, because 5 times 5 times 5 is equal to 125. Now, the properties of exponents that you've learned over the last couple of previous lessons all apply to rational exponents. So in this next example, we're going to be using some of the properties you've learned in previous lessons to simplify problems that have rational exponents. So in problem A, we have 6a to the 1/4 power times 3a to the 3/4 power. So hopefully you remember that you're going to multiply the coefficients, 6 times 3, and then to multiply like bases, you simply add the exponents. So this would be a to the 1/4 plus 3/4. So 6 times 3 is 18, and 1/4 plus 3/4 is 4/4, which is just 1. So when it's to the 1 power, we don't have to write the 1. So this would simply simplify to 18a. All right, look at problem B. Here, if we multiply our coefficients, we would be multiplying 3 times 1. And then for the a's, to multiply like bases, we add the powers. Now, if you feel uncomfortable adding fractions by hand, you can certainly put this in your calculator. I'm using Desmos here, but you can use any calculator. 1/2 plus, 1/2 plus 1/3. You just want to make sure that you express your answer in fraction form. So I'm going to press this little fraction button here, and it turns to 5/6. So this would be 3 times a to the 5/6. If there are no decimals in your original problem, you don't want to have any decimals in your answer. All right. Problem C, we have x to the 3/7 power squared. Now remember from our multiplication properties of exponents, we learned that to raise another power, a base with a power to another power, you simply multiply the exponents. So this would be x to the 3/7 times 2. So 3/7 times 2 would be 6/7. Again, if you don't feel comfortable doing that in your head, you can use your calculator. All right. All right, in problem D, we have 2x to the 1/5 power raised to the 3. Now, this problem's a little different because in our first problem, our coefficient was 1. In this problem, our coefficient is a 2. So I want to raise everything to the 3 power. So 2 to the 3 power times x to the 1/5 raised to the 3 power. So 2 to the 3rd power is 2 times 2 times 2, which is 8. And then multiply these exponents to get x to the 3/5. So 8x to the 3/5 power. All right, problem E is very similar. We have 49x to the 16, and they want us to raise that to the 1/2 power. So this would be 49 raised to the 1/2 power times x to the 16 raised to the 1/2 power. So we want 49 to the 1/2, which remember is the same thing as square root 49. So this would be 7. And here, to raise a power to another power, we multiply the exponents. So 1/2 of 16 is x to the 8. All right. Next problem, problem F. We have 27 x to the -9 raised to the 1/3 power. So I'm going to raise everything in the parenthesis to the 1/3 power. So 27 to the 1/3 times x to the -9 to the 1/3. Now 27 to the 1/3 power is the same thing as cube root 27, which would be 3, because 3 times 3 times 3 is 27. And then negative 9 times 1/3 is negative 3. So this would be x to the negative 3. Now, generally, we do not leave negative exponents in our final answer. So I need to send the x to the negative 3 to the denominator and go with the opposite sign. So this would be 3 over x to the positive 3 power. So again, we're having to apply a lot of the properties we learned in previous lessons. This is really great review. All we're adding is different types of exponents. All right, example 4. Let's get into some more complicated examples. We have negative 4, x to the 1/3 times negative 3, x to the 1/2. So we'll take our coefficients, negative 4 times negative 3, and then x to the 1/3. Remember, we add the powers when we're multiplying like bases. So negative 4 times negative 3 is 12, and this would be x to the 5/6 power. Again, you can use your calculator to add, well, we already did that in our previous example. 1/2 plus 1/3 equals 5/6. It's still in my calculator from our previous problem. All right. All right, in problem B, we have 4x to the 8 power times 36y to the 12 raised to the 1/2 power over 4x squared y4. Now, before we can complete this problem, we need to simplify the numerator because it's kind of got a lot going on. There's nothing we can do with 4x to the 8, so I'll just write that down. But we need to raise everything in that parenthesis to the 1/2 power. So this would be 36 to the 1/2 power times y to the 12 raised to the 1/2 power. So that would be, and again, we can't do anything to the denominator, so let me just write it down as is. All right. Now let's simplify the top. We have 4x to the 8 times 36 to the 1/2 is the same thing as square root 36, which is 6. And y to the 12 raised to the 1/2 power. To raise a power to another power, we multiply the exponents. So 1/2 of 12 is 6. So this would be times y to the 6 all over 4x squared y4. All right, now let's simplify the numerator a little bit more. We can multiply our coefficients here. We have 4 times 6, which would be 24. x8, y6, divided by 4x squared y4. Now we just have a division problem. So 24 divided by 4 gives me 6. And then x8 divided by x2. Remember, to divide like bases, we subtract the exponents. So 8 minus 2 would be to the 6th power. And then y6 divided by y4 would be y to the 2. All right, problem C. We have 144 a squared b14 raised to the 1/2 power. Pause the video and try this problem on your own. All right, welcome back. Let's see how you did. I raised everything in this parenthesis to the 1/2 power. And then I simplified it. So 144 to the 1/2 power is the same thing as square root 144, which is 12. A squared to the 1/2 power. 1/2 of 2 is 1, so that would be simply a to the 1 power, or just a. And then b to the 14 raised to the 1/2 power. 1/2 times 14 is 7. So check your answer with mine. If you made any mistakes on that problem, pause the video and correct those at this time. All right, pause the video and try problem D on your own. All right, welcome back. I raised everything in this parenthesis to the 1/3 power. So let me write that out for you. All right, so 27 to the 1/3 power is 3, because 3 times 3 times 3 is 27. Here, to raise a power to a power, we multiply the exponents. So 1/3 times 12 would be x to the 4. Here, 1/3 times 3 would be y to the 1. And 24 times 1/3 would be z to the 8. If you need to make any corrections to this problem, please pause the video and do so at this time. If not, we'll move on to problem E. So in problem E, we have 4x cubed raised to the 2 power times 9x to the 8 power raised to the 1/2 power. So I'm going to start off with my first parenthesis, and I want to raise everything in that parenthesis to the 2 power. Then I'm going to do the same thing to my second parenthesis, but I'll be raising everything to the 1/2 power. All right, now let's simplify that. 4 squared is 4 times 4, or 16. X cubed to the 2 power would be x to the 6. Okay. Then we have 9 to the 1/2 power, which is the same thing as square root 9, which is 3. And x to the 8 raised to the 1/2 power is x to the 4. Now, after I simplify everything, then I multiply my coefficients. 16 times 3 is 48, and x to the 6th power times x to the 4th power is x to the 10 power. All right, now I'd like you to pause the video and try problem F on your own. All right, welcome back. Let's see how you did. I simplified, or excuse me, before I did anything, I raised everything to the 1/2 power in the numerator. So x to the 24 raised to the 1/2, and then y to the 14 raised to the 1/2. And then there wasn't anything to simplify in the denominator yet. All right, then I said 100 to the 1/2 power is 10, because the square root of 100 is 10. 24 times 1/2 is 12. And 14 times 1/2 is 7. Then what I'm left with is a division problem. So I simplified that by saying 10 divided by 5 is 2. X12 divided by x to the 2 would be x to the 12 minus 2, or x to the 10. And y7 divided by y3 would be y4. And that concludes today's lesson, Introduction to Rational Exponents.